So hi everyone. Today we will be trying to figure out what are the different problems that one may face while using PCA in real world data. What are the disadvantages that PCA has, and later on we would be discussing about different versions of PCA that can help us resolve it in my coming up videos. So the one of the major most problem with PCA is that it struggles badly with big data. So if you know, like in the initial step, what we do is that we calculate a correlation covariance matrix for the dataset for which we wish to do the dimension reduction. But in case of big data, we really can't hold the entire dataset together in the same memory. Now, in such cases, the general implementation of PCA fails badly because if you can't hold that data in the memory for at once, you can't calculate the correlation covariance matrix. So how to do that? We'll be discussing that. Second being, this is a pretty known problem that PCA is able to detect only linear relationships between variables. If the variables are non-linearly related, then PCA fails badly. Fourth one being, assume that we have a humongous number of columns in the data, say 4 lakh, and eventually we know that only out of this 4 lakh columns we require just 400 in the final feature set. Now, if you know, PC is very computationally heavy. So if you have worked on even thousands columns, PCA would just die out. So is there any way that I can just roughly estimate on the 400 columns features that I have sort of an idea it might be useful out of the 4 lakh features that I have. Now the final being, at times what you wish is to do that when you feed in a sparse data set, what you wish to do is to generate a sparse data set out of PCA also. But PCA doesn't do that. So if you have seen a PCA metric, majorly what happens is that even if you feed in some sparse data set, the final output is dense expressions only. Now, where would this be useful? Where we would wish to have sparse outcomes only? Assume that we have a phase data set, phase images, and we're trying to reduce the dimension. Now in case of phase data sets, eventually if you can understand, there would be certain places in the entire image that would be filled in with values to indicate eyes, nose, the different features of the face, and rest of the values would be blank. Hence the matrix would be something of a sparse matrix only. Now eventually when you feed it into PCA, you would wish to have a sparse matrix only, so that the feature set remains the same, so that the model should be able to detect those features present in the image. But as PCA generates dense expressions, the features will get destroyed in the image. Hence, we would need to have some solution for this as well.